A parallel plate capacitor having plate area 20 centimeters square and separation between the plates is 1 millimeter is connected to a battery of 12 volt. The plates are pulled apart to increase the separation to 2 millimeter. Part A. Calculate the charge flown through the circuit during the process. Part B. How much energy is absorbed by the battery during the process. Part C. Calculate the energy stored in the electric field before and after the process. Part D. Using the expression for the force between the plates, find the work done by the person pulling the plates apart. And part E. Show and justify that no heat is produced during this transfer of charge as the separation is increased. So here we are given area of plate is as 20 centimeters square. So this can be written as 20 into 10 to the power minus 4 meters square. Plate separation is 1 millimeter, that is 1 into 10 to the power minus 3 meter. Now we find capacitance. So capacitance C, say this is initial capacitance, epsilon naught A upon D. We put the values. So epsilon naught, we will retain epsilon naught because it will be simpler. So I'm not putting the value of epsilon naught. 220 into 10 to the power minus 4 divided by separation is 1 millimeter, that is 1 into 10 to the power minus 3. So here it will become just 2 epsilon naught. Now, when plate separation is made 2 centimeters, so suppose we write as CF epsilon naught A upon D. So epsilon naught times area is 20 into 10 to the power minus 4 divided by separation is 2 into 10 to the power minus 3. So this time we will get epsilon naught. Now, let's find out initial and final charges. So Qi is initial charge, means initial capacitance, Ci into V. So Ci is 2 epsilon naught, and voltage is given as in the beginning voltage 12 volt. So this is 24 epsilon naught coulomb. Now final charge we find Qf, that is Cf into V. So Cf is epsilon naught and voltage is 12. So 12 epsilon naught coulomb. So this is final charge. Now the difference of the two will be charge flow. So charge flow will be 24 epsilon naught minus 12 epsilon naught, that is 12 epsilon naught coulomb, or 12 into 8.85 into 10 to the power minus 12. So we can evaluate it, we multiply, so we will get 1.06 into 10 to the power minus 10 coulomb. Now, energy absorbed. So, energy absorbed can be found by flowing charge times potential difference. So charge flowing is this much, 1.06 into 10 to the power minus 10 into potential difference is 12 volt. So we will get 12.7 into 10 to the power minus 10 joule. Now energy stored in capacitor. So initial energy, suppose it is Ui, so it will be equal to half Ci times V square. We put the values 1/2 Ci. So is 2 epsilon naught initial capacitance. So 2 into 8.85 into 10 to the power minus 12 times voltage is 12, so 12 square. So we can simplify it and we will get 12.7 into 10 to the power minus 10 joule. Now further, final energy we find U final is equal to half C final times V square. So 1 by 2 C final. This is just epsilon naught. So 8.85 into 10 to the power minus 12 into 12 square. So that will be equal to 6.35 into 10 to the power minus 10 joule. Now let's find out the work done. So work done equal to force into distance moved. Let's evaluate the force between the two plates. If you remember capacitor, so force between the two plates is given by 1 by 2 Q times E, where E is electric field. So we just evaluate 1 by 2 Q, and the electric field can be written as Q apart epsilon naught A. That is 1 by 2 Q square apart epsilon naught A. So this is force. So here we put this value Q square upon 2 epsilon naught A into distance moved. So distance moved is just distance is increased by 1 millimeter. So 10 to the power minus 3. Now we put all the values. So charge we have calculated as 24 epsilon naught. So that will be whole square divided by 2 epsilon naught into A. Area is given as 20 into 10 to the power minus 4 times 1 into 10 to the power minus 3. So we can simplify, and this will be equal to, after simplification, we will get 144 epsilon naught, because here there is a Fermat square. So 144 times 8.85 into 10 to the power minus 10 to the power minus 12. That will come out to be 12.7 into 10 to the power minus 10 joule. So here, work done equal to energy absorbed. This is work done, and we have calculated energy absorbed here, and that is same. Now, question number 45. So, a capacitor having a capacitance of 100 microfarad charged with potential difference of 24 volt. The charging battery is connected and the capacitor is connected to another battery of EMF 12 volt. With the positive plate of the capacitor joined with the positive plate of battery, find the charge on the capacitor before and after the connection. Find the charge pole with the 12 volt battery. Is work done by the battery or is it done on the battery? Find its magnitude. Find the decrease in electrostatic field energy. Find the heat developed during the flow of the charge after reconnection. Let's consider the solution. So if the solution is, first of all, let's find out the initial charge, that is CV. So we put the values 100 microfarad, so 10 to the power minus 6 into 24. So that will come out to be 2400 into 10 to the power minus 6 coulomb. And then we find final charge QF, that is CV. This time voltage decreased to 12 volt, so 100 into 10 power minus 6 into 12. That is equal to 1200 into 10 to the power minus 6 coulomb. Now, charge pole will be the difference. Charge pole will be equal to 1200 into 10 to the power minus 6 coulomb. Work done on the battery equal to W, which is charge pole times potential applied by the battery. So it is 1200 into 10 to the power minus 6 into here potential is 12 volt. So this will come out to be 14.4 into 10 to the power minus 3. Now, energy stored, initial energy 1 by 2 C V1 square. So and final energy will be equal to 1 by 2 C V2 square. Now, if decrease in energy equal to energy difference, that is Ui minus UF, that would be equal to half C V1 square minus V2 square. So we put the values, this would come out to be 1 by 2 into 100 microfarad, that is 10 power minus 6 into 24 square minus 12 square. So if we evaluate it, it becomes 21.6 into 10 to the power minus 3 joule. And after connection, so here, after connection energy will be connection energy equal to half C V2 square, and that will be heat developed. So heat developed equal to 1 by 2 into 100 into 10 to the power minus 6 times 12 square. So this will become 144 divided by 2 into 100 into 10 to the power minus 6. So this will come out with 7.2 into 10 to the power minus 3. Thank you for watching.